What's going on, everybody? Welcome to another episode of Adventures in DevOps. I'm your host, Will Button, and joining me today, this is going to be exciting. I have the founder of Pganalyze and a member of the founding team at Product Hunt. I've got Lukas Fittl. Welcome, Lukas.
Thank you. Happy to be here.
Right on. I'm excited to have you. And this follows on nicely to an episode we had 2 episodes ago talking about the role of DBAs in our environment, with our with the movement that's happened over the last decade. Whenever I started, DBA was like the premier role to have in technology. Being a database administrator was like the ultimate role because you could just say no and shut everyone down. And, the company was almost powerless to do anything about it. Not that that was your goal, but like that was the prestige that the DBA had. And these days we just don't see as many DBAs around, but those tasks that the DBAs do still exist. And so I'm interested to hear your perspective on that. But before we jump into that, give us a little bit about your background, how you got to this point.
Sure. Yeah, and I'll try to relate this to Postgres, which is a database I care a lot about. So over the years, I essentially started out in 2006, 2007, putting servers in racks. But back when we still had racks,
Right.
we still do have racks. It's just you don't think about them anymore. They're a logical concept more than a physical thing you think about. And so, pretty much, early, like right after that, kind of first job I had, I, kind of started a startup with some friends of mine, and Postgres was a database of choice, right? And so, back then, we kind of just had everything stored in our Postgres. And as my personal career went on, I kept, seeing Postgres over the years, right? And Postgres is an old database. Like it's not as old as I am, but it's close to it.
Right.
And so it turned, I think, 27 years last year. Postgres did, not I. And so really the story here, right, is that I think what I've seen over the years in my career, right, is like Product Hunt, for example, used Postgres as my database, right? Like Product Hunt as a community. The database was, reasonable, not the biggest database, but it just worked, right? Like you just had the system of record, and that was Postgres. And then after that, I joined a company called Citus Data. And Citus Data is essentially a way to scale out Postgres. And that ended up being acquired Microsoft. So, I had some fun in the corporate world for a little bit. And then, really what this led me to is where I'm at currently, which is a company called Pganalyze. And so Pganalyze is a small startup, bootstrapped very intentionally, so no VC funding. And really the idea is that we want to make Postgres work better, right? Postgres performance in particular work better for the application engineers, the DBAs, the data platform engineers, help you optimize slow queries better. I've actually run this as a side project before, I went full time. So I actually started it technically like almost 11 years ago.
Oh, wow.
But, only I would say the last 4 or 5 years has been really a serious project, right?
Yeah.
So before then it was more of this was, solving a problem. Some people are paying for it, but really, as a business, it's really been, the last couple of years where it has taken off and we've really seen great success.
Right on. So you kind of, it's one of those, sounds like it's one of those stories where you had a specific problem personally and you built this tool to solve it and then realized, hey, other people kind of have the same problem.
That's right. Yeah, and I actually, so I had a friend who he was involved early on with the project, but is no longer. But I had a friend who was essentially my go-to Postgres person, right? So if you asked me 10 years ago, I probably wouldn't have been as smart about Postgres as I am these days. Definitely not the smartest. There's definitely smarter people out there, but I've learned a thing or two. But back then, essentially, he was a person I would ask, how do I optimize this query? How do I, set this thing up so it works well? How do I do the replication? And so, really, in part of scratching my own itch, essentially, was this is a person that's great, but there's some tasks that just don't seem necessary for a person to do manually, right?
For sure. Yeah. And I think that's one of the things I've encountered as well is like I have in my own network, like, oh, this dude is my go-to guy for that. But it's a personal relationship, and I'm always concerned with, making sure that that relationship goes two-way and that I'm just not beating these people up with questions. So yeah, I see the need there to build that. So what What were some of the like big things that you were trying to accomplish with Postgres or do in Postgres, or how did you even know that these were things that you needed to be worried about?
I mean, the simplest thing is just a slow query, right? Which I would say basically everybody who runs a Postgres database will run to a slow query at some point. And this
Right.
is not, just Postgres, right? It's just any database really. Queries are a thing, right? Like that's your basic unit of work essentially. And so I think the most fundamental thing is the database doesn't behave as I expect it to, right? Like it's not as fast as I expect it to. It's returning less data than I expected to, like whatever it's happening. And so really, I think that was the most fundamental thing is understanding which queries are slow, right? Sometimes you have visibility problem because sometimes on the application side, you're actually calling a function like in your ORM, you're not really thinking of the database as queries, right? You're not actually running SQL.
For
So
sure.
sometimes it's just a visibility problem. But then once you know which query is slow, there's a question of why is it slow, right? How do I go from knowing it's slow, that it's like kind of this magic box of activity, to actually the database is doing this index scan, it's doing this sequential scan, it's doing this join, and maybe there's a better way to join things, right? So there's essentially different choices of how the database implements what you tell it to do, and so this is, I think, really the most fundamental thing that I've seen myself need to know about databases is why things are slow and can I do something to improve them. And then the more you have an expert at hand, really what the expert I think can do is help you understand which action to take, right? And the action might be something like rewrite the query, kind of get database to choose a different query plan. There's like different ways to have influence what's going on, but understanding as you have a slow query problem in the first place, I think that's really the most fundamental thing to start with.
For sure. Yeah. And I'm glad you brought up ORMs because they are like, I think anymore, that's like the default in interaction for a lot of engineers with the databases just through the ORM. And you don't see the queries that they create a lot of times. And I've seen quite a few instances where when the database performance slows, the first response is always to increase the size of the database server, and
Right.
then you get that bill. You get the AWS or the GCP bill, and that's whenever the finance team comes down and says, "Hey, maybe we should take a different approach to this." And so that's where that's whenever you got to break open the hood on the ORM and really start understanding what queries it's running and is there a way to optimize those.
That's right. Yeah, and since you talk about costs, right? I think like these days everybody's like optimizing for costs, right? Because like things are
Yeah.
expensive and companies are laying people off and all the bad stuff. And databases are interesting, right? Because they're quite expensive, but they're also hard to change, right? And so I think that's something else I see often is really like, as you mentioned, right? Like this, like people reach kind of a performance bottleneck, but then they don't know how to solve it, and so they just upscale database. And
Yeah.
what's worse is usually in the cloud, your databases go up in sizes of two, essentially, or multiple, like power of two type things, right? So
Right.
like you have 16 gigabytes of RAM, next you got to have 32 gigabytes of RAM, and then it's 64, right? And so you just
Right.
keep essentially like doubling your costs, which is horrible, right? Like
Right.
and it's really hard to not do that because you can't just like have multiple database servers. Like that requires re-architecting. Like you actually have to think about, can I use read replicas and like to like split up the read workload, and so stuff like that becomes a challenging problem, right? And so this is where if you can figure out a query performance issue without scaling up your database server, right? Because you're adding a missing index, for example, then that can actually save you a lot of money, which is why people care about it.
Oh, for sure. Yeah, and I'm not a DBA by any stretch of the imagination, but the power of indexes, whenever I discovered that early on in my career, was just mind blowing at how much of a difference that would make in the database performance.
Yeah, for sure. Yeah, and I mean, the good news is I think people have gotten better over the years at understanding the basics of indexes. I think where it's hard to, like, what's hard to understand with indexes sometimes is that there's multiple different index types, right? So Postgres, like the default is a B tree, which most people roughly know conceptually what a B tree is. But Postgres has all these different index types, like gist, gin, hash, brin, all these like specialized things. If you're talking AI and ML, there's kind of PG vector has like IVF flat and HSV index types, and so really the challenge there is understanding when you use these specialized types, right? Like
Yeah.
that's essentially what's even worse than the regular indexing problem is just oh, I forgot to add an index. It's which index to add.
Right. Yeah. Just information overload. right off
Exactly.
the
Yes.
bat.
Yeah.
So everyone's talking about AI these days, and I think one of the stories that we're trying to sell really hard is that AI is not the tool to replace your job. AI is a tool that helps you be more proficient at your job, because as an engineer today, like, you've got to be versed in so many different things, from infrastructure to databases to the actual application code that you're writing to the business knowledge. So what kind of assistance can we get from AI in helping understand things like that, like where we need an index and what type of index?
Yeah. And I think it's a complex topic, right? So I think the answer is, I think there are things we should be thinking about. Is it important that a human is doing this activity, or can we be machine assisted at the very least, right? I don't
Yeah,
necessarily know if we want to be machine driven, right? I don't know if we want to have the AI kind of take control of our database tuning, for example. I
for
think,
sure.
very much the same way that if you think of the DevOps world, right? Do we just want to have, AI orchestrate our servers automatically and just provision things? Probably not, right? Like things like Terraform and stuff are a good thing. Like you want to have that level of control. And so I think with I mean, there's a couple things going on in that field, right? So I think just looking back over the last couple of years, looking outside of what we ourselves have done, maybe just start with what other people have done. So just in terms of research, there used to be a project called Autotune. They're a company now. They essentially do. I'm hazy on these details personally, but they essentially do like Bayesian statistics-based optimization, right? So they do not use generative AI, right? Like it's not like you're asking ChatGPT how to optimize your database. What they're essentially doing is saying, for this particular parameter value, can we run, a model that essentially comes up with the best possible parameter, right? And it's pretty nifty. Like it's a cool idea. It's a cool system. Um, there's another startup like that, DBTune, which also tries to do something very similar, more recent, similar idea, right? Which is, how can we get the best parameter values essentially? And so I think that's great. You should take a look at these if you're interested in tuning parameters. What we have done as Pganalyze is we've optimized or focused on essentially the things that, they're a little bit more fuzzy in terms of who owns them, right? So you tend to touch on indexes earlier. And so what we've actually come up with is a system called Pganalyze Index Advisor, which is essentially a recommendation system for which indexes to create, right? And so different than parameters, right? A parameter is sometimes a choice. Like you kind of want to fine tune it, but you don't necessarily need to do that all the time, or your application engineers don't need to know how you tune your shared buffer parameter in Postgres. Like that stuff isn't that important essentially to the application engineer. But indexes are interesting because they have like this fuzzy ownership, right? Like, is it the application engineer owning them? Is it the kind of DBA or data platform engineer owning them? And so what we essentially built is a system that, you know, imagine it's kind of like your safety harness, right? Like it doesn't necessarily say you've got to drive your decisions, but if you forget to add an index, it will tell you.
Right.
And so it's not, would I call it AI? I don't know, right? AI is a complex term. It's not Gen AI, right? Like it's not generative AI, the same way as Autotune or DBTune are not generative AI. But it is a way to essentially have a recommendation kind of which things to create based on your career workload, right? And so, similar spirit, what we've also done is what we call Vacuum Advisor. And so, Vacuum in Postgres is a very particular concept. You may not be familiar with it, but essentially, it's essentially the dead row cleanup in Postgres, right? So, like when you have like you doing update or delete, Postgres, will create essentially a record that kind of just marks the deleted data essentially, and then Vacuum comes and cleans that up. And so sometimes you need to fine tune the schedule of that, right? You need to understand how often is it running? Is it running too often or not often enough? Is it, kind of like like running at the wrong time of day, right? Like I have my business hours and suddenly my database is busy with Vacuum. And so we've essentially done something where we looked at all the time series data that we have in our system and we said, can we make you recommendations for which config settings to change? So this kind of goes a little bit into that parameter tuning area. But what we then do is we do this on a per table basis, right? And so this is then again where if you as a human did that, it just becomes very complicated, right? Because you got to think of like, imagine in our own database, for example, we have 1,000 tables. If you have 1,000 tables, looking at each and every one of them, and then looking at a graph over time that describes to you how the auto vacuum works, is just very tedious. And so, being able to have that automatically kind of looked at and analyzed is really what I found quite useful over the years and what we've done.
Oh, for sure. To me, that's like pure gold right there, because like, I know that you have to vacuum Postgres databases, and when I first encountered that, I was like, what the hell? I have to vacuum this thing? Like, can I hire a
Well,
housekeeper or how does this work? And
and I
then
mean,
it's like,
there's the
well, when
built-in
do you want to
housekeeper.
do it? Yeah, yeah. And then, so then, yeah, that just led to more questions for me. Like, well, should I trust this built-in housekeeper? When's it going to do it? How do I know if it's doing it at the right time? And
Right.
so to have a tool that looks at what's actually going on in my database and then makes recommendations based on that activity, I think is just like an amazing resource to have because it answers so many questions for me that I didn't even know were supposed to be questions.
Right, exactly. Yeah, no, and I think especially if you like are not a Postgres expert, right? Like this is what I've
Yeah.
seen over the years is like people migrate from Oracle to Postgres or from SQL Server to Postgres, and these databases they do this differently, right? So they don't have vacuum as a concept, and so people when they first go to Postgres and then they have this big production system, suddenly these vacuum problems start happening, and they're like, "What's going on? Like, what should I do?" Right? Like I don't have anybody in house who knows about this. So
Yeah. Yeah. And can always post on Stack Overflow and hope for the best there.
there are some good people in Stack Overflow. Like, let me
There
tell you,
are.
like,
Yeah,
it's really, I've learned a thing or two or 10 from Stack Overflow posts.
for sure. Yeah. It's funny because like there's the learning curve of Stack Overflow. Like it's this tremendous resource, but you have to learn how to interact with it, how to here's the minimum criteria I have to open the question, and here's what I've got to include if I'm going to get a legitimate, valid response.
Right. And I think what's interesting, so on the topic of Stack Overflow, that actually makes me think in terms of AI. That makes me think of Gen AI, right? Like the
Yeah,
whole, kind of give me a response that resembles Stack Overflow answer is, I think, what generative AI and LLMs are good at. And so somebody in Postgres community, Nikolai from Postgres AI, he's recently on a project where he's essentially connected ChatGPT with kind of a knowledge base of different Postgres articles. And it's actually a really interesting experiment, but he's essentially saying, what if we had a chatbot, that was powered by ChatGPT or GPT-4, I think, and then you would essentially ask it questions like, how do I set this parameter in Postgres, and then it will just spit out something that essentially looks like a Stack Overflow answer, which I think like that has its place as well, right? Because I think what people do alternatively to asking a chatbot that is they'll go on Google and they'll search how to tune this parameter. And then unfortunately with the advance of AI, what has happened is a lot of more articles are just not that useful because
right.
it's become pretty cheap to generate kind of bad content in a sense.
Yeah,
And so what he's done is really kind of I think built a better solution to how do I get good Postgres knowledge, is by essentially building off of GPT-4, and having kind of this more trusted, I think, database of good articles, which I found interesting.
yeah. I don't think it's going to be truly successful though until ChatGPT actually sends out insulting answers at random just to insult your intelligence and tell you to come back when you actually know how to ask an intelligent question.
Yeah. Yeah, and it has some weird issues. Like earlier this week, I'm not an active ChatGPT user personally, but there was like this issue where it just like started spewing random garbage. Like
Right.
it's certainly sometimes I mean it's interesting in a sense, right? Like it feels like I'm reading a science fiction novel and I'm not yet sure where it's going.
Right. Yeah. Cool. So let's go back to someone who's working with Postgres, has multiple other roles, and we talked about the need for indexes and query optimization, but that's like pretty specific. Like you're narrowing in on the actual problem there. What are the indicators before that tell them that this is the area you want to focus on? Like you're running Postgres, what kind of things do you see that tell you, hey, this is a something that Postgres might help with versus this is something that looks like it's application code or
Mm.
infrastructure related?
Yeah, yeah. No, it's a good question. So I think it's actually not an easy problem to solve, right? Because you're kind of looking at two different worlds, right? So I think what people most commonly would have is they will have like an APM tool of sorts or tracing tool, right? So they might be
Mhm.
using New Relic, Datadog, like long list of APM tools, right?
Oh, for sure. Yeah.
And so what you would see in these tools is you would see a trace, for example, right? These days you would call it a trace. And you would say, here's a slow request, and you would see different spans essentially in a trace that would say, which part of the request is slow. And so usually with most of these instrumentations, from the application side, you will know that the query is the slow part, right? So I would expect, let's say, with a request that takes 10 seconds, we would see that, out of these 10 seconds, 9 seconds are spent in this database query, right? So this is actually something that you will get most of the time. Now, the hard part is understanding, is this something I could do something about, right? Because it essentially will say, here is a SQL query, and here is, this 9-second span, but it doesn't tell you anything more about it. And so what I've found quite interesting, what we've kind of launched this as a feature also last year, is we essentially use the fact that OpenTelemetry allows you to connect essentially different services, right? So the idea in a microservice architecture is you could have different systems send into the same trace essentially. And so imagine that if your database could tell you, hey, these 9 seconds of time, actually I spent 5 seconds scanning this index, 4 seconds joining this data, right? Suddenly your trace becomes much more usable, right? Because you're not looking at this 9-second time span. You're actually looking at individual operations that you maybe understand better, right? Because you're doing a big query on this table. And so what we've actually done essentially is piggyback on this idea of different services sending into same system, same observability system. And so we've built an integration where we pull the kind of the slow query log, or rather auto-explained log in Postgres, which essentially says, here is a slow query execution, and here's the plan for that execution. And so we pull that as part of our kind of agent, and then we send essentially a reference of that information into the tracing system, right? And so what this solves is what you would do otherwise, right? So let's imagine if you don't have this type of solution, is you look at your trace and you have that 9-second span, and then you have to correlate that with the database activity, right? So you would essentially either look at your database logs, or like in Postgres, there's tools like pgstat statements, which tracks the query performance over time. And so what you would do is you would essentially say, well, I know roughly the query shape, right? Formatting sometimes differs slightly, but maybe, I'll like copy and paste a part of the query. I'll go over to a database and I'll kind of put it in, and I'll try to find the thing that's matching, that looks like the right query. But it's really hard to do that precisely. And so this is, I think, where OpenTelemetry really has an interesting way of solving this, right? Because just expanding that briefly, what essentially it does is, so in tracing, you have these IDs, right, that you're trying to propagate across systems. And so the idea is, when you run a SQL query, you add a comment, and in the comment it says what's the trace ID and the parent span ID of that query is. And so when the query arrives on the database side, the database can output a log, for example, that says, hey, this query was slow, here's the query plan. And also, by the way, here's the little comment at the start that tells the tracing system essentially how to kind of stitch that back together into one unified view of the world, right?
Yeah. And that's the OpenTelemetry has just made some huge strides in tying all of that together. We had Andy Grabner from Dynatrace on the show yesterday, and we ended up talking about OpenTelemetry there as well, and just the whole the whole community effort from all of these different players to agree, like, hey, we can all use this standard and create this system that allows you to tie those kinds of things together is pretty cool, and something that I don't think we could have seen in our industry up until the last few years.
Yeah, for sure. And I think OpenTelemetry is interesting because it has that like cross-company collaboration, right? So like Dynatrace is involved in some of the standards. Microsoft, other like big players are involved. Like it just seems like I'm positively surprised essentially that they were all able to come to the table, and like some of them are vendors, some of them are big customers of observability data. And even if some of them are selling their own solutions, right, they are essentially still at the table discussing, hey, how can we make the standard work?
Yeah.
Which is end user is actually great, right? Because you kind of go out of this vendor specific instrumentation in your code, and you're moving more towards the standardized instrumentation, and you can choose different vendors. So I think that's how things should be.
Yeah. Yeah. And then the skeptical side of me sees that and is like, okay, what's the catch?
I mean, I think the catch is it's sometimes the story is a little bit oversold, right? So I've spent a little bit of time in some of some of the maybe more niche use cases, right? And the whole thing we just I just talked about in terms of commenting and such. Like, for example, there's a project called SQL Commenter, which is supposed to add these different query tags in the beginning. And that's a project that Google actually donated to the OpenTelemetry project. And it's great, they've donated it, but also it's kind of stalled since then. So it's not like they've actually pushed forward and really said, hey, how do we make this, proper standard? How do we document this as part of the official project? And so sometimes I think the risk essentially of these standardization projects is that sometimes, there is like this, alpha spec to do something, or like this thing that was contributed by one of the players, but there's not enough momentum around actually developing the standard further. And so I think, for example, if I was doing tracing, right, definitely do the OpenTelemetry tracing stuff. But if you're doing logs even, right, like logs are like, they're pretty stable in OpenTelemetry, my understanding, but they're still less, kind of commonly kind of fully supported across all different languages and whatnot.
Right.
So,
yeah. So you've got a ton of experience with Postgres. There's quite a few database choices available. I mean, really, in my mind, there's Postgres, MySQL, and Mongo. I consider those to be like the big players, and there's different variants of that, and when you get off into the NoSQL stuff, there's different use cases there. But I really see it as being like those three as being the most prevalent. What are the things? And I've used Postgres a ton because it just seems to fit any use case you throw at it. But what's your take on why Postgres versus some of the other database offerings?
Yeah, and I would add, like, just to add a fourth to the list, I would say these days I would add ClickHouse to the list as well in terms of
Okay.
open source databases. It's not relational, it's a columnar store essentially.
Okay.
But I've definitely seen a lot of companies use Postgres and ClickHouse for different parts of workload. Yeah, I would say it's so I think that, like, there's different reasons why to use Postgres and why to use different ones. One of the things that you just talked about OpenTelemetry and different companies coming together, right? And so from a community perspective, the one thing, like, what keeps me in the Postgres community, right, which is not exactly answering your question, but I think it is an interesting aspect to this, is Postgres is not a project by one company, right? Postgres is a community project. Like, it has, people from AWS working in it, people from Microsoft working in it, people from EDB working in it, people from Google working in it, people from small companies working in it. And it is a true community project, kind of like Linux currently is. And I think this is what fascinates me about it, and what makes me, just the longevity of it is like so much. Essentially, like, I trust it to have that longevity even in 10 years, 20, 50 years from now, just because it's been able to kind of advance over the years, but it's also been able to do that as a community project, not as a commercial player trying to kind of get both benefits essentially, right? Because if you look at MongoDB, like, MongoDB has their Atlas service, and I don't know how it differs between what MongoDB open source gets you versus the Atlas based MongoDB, but certainly I would imagine they have that conflict, right? They're constantly thinking, what should I put there? What should I put there? Are people just going to deploy their own, right? And so just that is really, I think, why Postgres is a great building block, right? Because it doesn't have that fundamental conflict that these companies usually have. I think when you're trying to make a decision which one to use, I think if you're using MySQL, there's some reasons to migrate to Postgres, but they're usually not that strong, right? So I think when I see people migrating between databases, it's really more the old school, like Oracle or SQL Server, to Postgres, right? And for example, Postgres is a very good target for these migrations because it has like a lot of similarities in some sense in the query language and such, with Oracle, for example. And so like it's easier to migrate essentially to Postgres than to MySQL. Also, if you're using Oracle, why would you go to MySQL? Because that's owned by Oracle again. So you kind of, doesn't really make sense. And I think MongoDB, I don't have much experience personally, but I think it's like really it's the kind of thing where you make a choice. Sometimes companies run multiples of those. Like, oftentimes I see companies just standardize in Postgres. I think you can scale out all of these, right? Like, Postgres has Citus, MySQL has Vitess and PlanetScale. MongoDB kind of has its built-in way of scaling out, so it's you don't really run into a bottleneck these days anymore with not being able to scale beyond a certain data point.
Yeah, for sure. My introduction to MongoDB was, I think it's been over 10 years ago now, but where we used it was with mobile applications and user attribution, because you have this application that ties into all of these different services, like ties into Facebook and ties into Amazon and different things like that. And you're trying to attribute your marketing campaigns to those platforms. But with each one, you get different data.
Mhm.
And so Mongo for us turned out to be a really good way to just say, okay, here's the attribution data we got for this user, and we're just going to put it in this Mongo field. And then in some cases, we know that there's one key value pair that's consistent across all of those platforms. And then we're going to keep the rest of the stuff around because we might end up needing it later too. And so that was a really strong use case for Mongo. Now, Postgres also, though, supports JSON data types. So you could just as easily have done it with Postgres. I don't know if Postgres actually had it back when we did this, but I know that it is there now.
Yeah, and what it probably had, so there's, I would say there's three things worth thinking about and knowing about, right? So like the simplest thing is you could always just store text, like JSON as text in your database, right?
Right.
But what you're kind of losing there is like any sense of validation, right? Like if you're missing a parentheses, the database is not going to tell you, right?
Right.
And so the most simplest form, Postgres has a JSON data type, and JSON in Postgres is really just a validation step, right? Where it says, okay, well, let me confirm that this is actual correct JSON, and then it can do some operations on top of it. But really, where I think Postgres has become more of a competitor of MongoDB is the JSON-B data type. B stands for binary.
Mhm.
And the idea behind that is that it lets you, amongst other things, index a JSON-B kind of field, similar to how you could index it with Mongo, right? So like the idea is that if I have this like schema-less data of sorts, like I don't know exactly the shape of it or what gets thrown into it, but I usually want to query for some of the keys, right? And I want to search for things in that haystack, essentially. Then the way that you can do this nowadays with Postgres is you have a JSON-B, you have a GIN index, or I think in some cases just indexes on the JSON-B column, and then you could just do queries on it, but you don't have to declare upfront what you're going to query, right? You don't have to say, I'm always going to query for, this campaign ID field or this, other kind of whatever the fields are, but you could actually have it kind of more generic index. And so that's really, I think, what, these days, if you're storing JSON in Postgres, definitely use JSON-B because there's no reason not to, or almost no reason not to. And so that I think, gets you 95% of the use cases that MongoDB usually would have.
Yeah. And you're still in a database platform that supports relational
That's right.
data as well. And I think to me, that's huge because every application, every business does have relational data. And so now you're able to accomplish that in a single database platform versus juggling multiple database connections and trying to remember which one has which data.
That's right. Yeah, and on that note, more recently, also, so talking about AI, we like in the Postgres community, somebody, Andrew Kane, created a project called PG Vector. Excuse me, PG Vector. And PG Vector essentially does is it stores vector embeddings inside Postgres so that you don't have to use a dedicated vector database. Instead, it's essentially the same idea, right? Like you have essentially a special like column like data type that has special indexes, and then you can store, like if you're trying to, build all these AI applications, instead of now using specialized databases, you can just use your Postgres. And really the big benefit that people are seeing these days, right, is that they can then also keep the rest of the data in Postgres, right? So you're
Yeah.
building your cool fancy AI startup, you can now, use Postgres for everything, up to a certain limit, right? So there are still benefits to using a specialized database, but especially when you're starting out, it's just so much simpler to just stay within one system, and then later on, you kind of scale it out. Um, and I do want to mention at that point, right, the reason we talk about different database technologies, one of the reasons why Postgres is very good at, kind of supporting these newer things like the, embeddings, is because it has a very good extension system. So compared to, for example, MySQL, it's much easier in Postgres to create an extension that changes some of the core functionality in Postgres that hooks into different parts. There's more of a community around that also that, kind of releases these extensions. And so the fact that, somebody like 2 years ago, Andrew Kane was like, yes, I'm gonna, build this library called PG Vector and I'll just publish this, as an extension for Postgres. And then, all the big cloud companies like AWS, GCP, Azure, they're all like, yes, AI, it's the best thing. And by the way, we support AI. And then you look at it and it's just PG Vector kind of, sitting under in the database, essentially. Like they just went and used the extension. I mean, it's cool. They did it, right? Like they made it accessible and usable. But it's fascinating how that extension system allows this adaptability of Postgres essentially.
Yeah, for sure. And I think that sets up the stage so that you can empower your engineers so that they can focus on application performance, right?
Yeah, that's right. And I think also not learning about a completely new system, right? Because they will have
Yeah.
to, install a new driver, probably like on the application side. Their ORM probably wouldn't support it, right? Like there's all these extra steps that they would have to take if to use something completely different. So
Yeah. And going back again to talking about the number of technologies and fields we have to have expertise in, really that's like the overall objective for all of those is to create a performant app that moves our business forward, because most of us are not in the business of running Postgres databases or building AWS infrastructure. That's just the means to an end for whatever our company is actually trying to do.
100% agree.
Where do you see Postgres and Pganalyze going from here? Because we're still in the early stages of AI, still trying to figure out what it
Mm.
means. And I think you might agree with me that AI is not a job killer, but a job enabler.
I would say it's complicated, right? I think for some
Yeah.
people it's definitely a job killer, right? So if you are in the creative industries and let's say you used to let's say you're an artist, but you used to get money from, working in advertising campaigns. Well, turns out, OpenAI just released Sora, which, makes your whole video production pipeline much easier to, just automate with AI. And so maybe you're out of a job, right? Because like suddenly your creative industry's job is just no longer paid. Like you can still keep being an artist, right? But there's just
Yeah.
no money to be made. So I would disagree saying, it's definitely taking jobs, right? Like that is very clear. Um, I think that's in a sense how when change is happening that happens, but it's also shitty, right? Like it causes all kinds of problems. So
Yeah.
I think
Fair
we
point.
have to accept that too. Um, but I think when I think about more personally in terms of what do I see, right, like happening in my like niche of the world, right, which is like engineering and database optimization. I think, as mentioned, database optimization, I'm not sure how much it is a generative AI problem, right? So there, to me, the natural language aspect of it is more a maybe there's a semi-automated system that can solve some of these problems for me, but instead of me having to interact with the user interface where I click around or like maybe I have to write some code, instead of that I can just talk to my quasi admin of sorts, and it just happens to be to be a large language model type interface, but behind the scenes what's actually doing is something much more deterministic, essentially, right? Like it's driving another system that really makes the smartness essentially work. um, I think in the context of engineering, obviously GitHub Copilot, for example, I think does have some interesting aspects to it, right? And so I have not seen it fully solved. Like I would wish it could write my tests for me, right? Like when I
Yeah.
write code, I hate writing tests. Like it's just like I'm lazy. And so what if I could just have Copilot write it? But then the problem is intent, right? Because like it doesn't replace the intent. Like you have to still tell it do this, do that, create that. But it does kind of take a little bit of the activation energy away, right? Because sometimes when you have a tedious task where there's a lot of things to do, it's just hard to get started. And so what I've heard from at least other people, and I've sometimes seen a little bit myself, is that the that's today already a value that something like Copilot can deliver. And so I think if we project forward, right, I don't think the thinking goes away, right? I don't think like none of the large language models are thinking, right? They're not reasoning, they're just like generating.
Yeah.
And so I think really it's a question of how do we like it's a question of like how do we drive these systems, right? Like how do we as operators, as engineers, drive a system in a way that makes predictable outcomes but automates the things that are either hard to like they just like take a lot of time, they may take a lot of expertise, right? And so I think there's a lot of opportunities there, but I don't think the human goes away that drives essentially this is how the system should work or behave.
For sure. Gotcha. So it's a way to provide the technical expertise, but you still have to apply like the is this a good idea?
Yeah,
So,
or like the bounds of it, right? Like
yeah.
maybe it gives you suggestions as hey, like it's kind of like we're doing with indexing, right? So like today, if I look at our solution for indexing, it's okay. Like it could definitely better, right? Like it gives you a reasonable, good recommendation. But I think over the years, what I'll see, us do, right, is like at PGanalyze, our index recommendations will actually get to the point where 90% of the time they are just good, right? Like they're something that an expert would give you as well, and you can just apply them. But still, I think the decision of when to apply them, how often to apply them, which level of testing to do. That is something that a human operator should essentially take into account and decide. Because I think otherwise, you don't really have control over the system, I guess, right? Like you'll have, things be unnecessarily expensive and it could be cheaper. You maybe have, things be slow because the system optimized for the wrong thing. And so I think that there is this level of control that I anticipate us needing ever so, ever more so in the next couple of years.
Yeah, it makes me think of the Jurassic Park meme with, I think it's Jeff Goldblum, where it's like, you were so focused on whether or not you could, you never stopped to think whether or not you should.
Mm-hmm. Yes. Definitely something I think of when I see some of the things AI does.
Yeah, right. So what are the big problems that beyond index and query tuning, what are some of the big problems you see with Postgres that fall into the "I wish I'd known that sooner" category?
Yeah, good question. I think there are some things like, let me see how to put this. So if you have a lot of data, like terabytes of data, you
Mhm.
can definitely store it in Postgres, right? So like Postgres doesn't really have a limit per se. I think the one thing that I have definitely seen is if you anticipate, scaling hugely to the point that you'll have 100 terabytes of data, it really does help to think a little bit about how you may be able to split up your data potentially, or at
Yeah,
least how it should be structured in database. So I'll give you two different examples of this, right? But essentially, data modeling of some sort is what I'm going for. So one example is back when I was at Citus Data, right? So Citus is a sharding system. So you have different database servers essentially, and you scale your workload by adding more servers, which generally is a very good pattern. Now the problem is if you're looking for a record, right? So let's say we have users. Well, let's say we have users. We have billions of users, right?
mhm,
So we have all these servers, right? And like a certain subset of our users are in each server. And so if we're looking for a particular, let's say, email, what we'd have to do, right, is we'd essentially have to run a query across all these servers, right? Which, like, the more servers you have, the more complicated that becomes, and you can parallelize a lot of that, right? But like essentially, then you have problems with too many connections, and so like generally speaking, it's not good if you have a lot of queries that go across all the servers. And so when you have this type of scaling out anticipation, one thing that I always do these days is I make sure that I think about how could my data potentially be sharded in the future, right? How could it be split
yeah,
up like that? And then oftentimes, like let's say you build a sales tool, right? And the sales tool has like B2B customers, right? And so you have all these customer IDs, right? And so in the most naive implementation, you have, maybe a customers table, and then you have a CRM records table, and that has a customer ID. But then maybe each record has a comment, and so the comment just, includes the record ID, but not the actual customer ID, because you're like, that seems duplicative, right? Would I copy this, same value all over the place? And so the thing I would actually do if I'm anticipating to scale is I would actually include my customer ID in this case in all my tables, because that's the one thing that makes it a lot easier to shard out your data. Is if it's very easy for you to say, if I have, my 1 terabyte table, which subset of the table belongs to each customer. And then when I'm going to move, like 10% of my customers to this other server, I can just, select, essentially by customer ID, versus doing a very complicated join that actually becomes quite expensive once your system
right.
is large. And so that's the one thing I would do to anticipate scaling, is to really, think of that. What's your unit of subdivision essentially in your data? Is there a way to like potentially just add that ahead of time, so that you have a better chance scaling in the future, essentially without much effort. And then the other thing, again, data modeling related, that I found recently is just there are some tips and tricks. This is really kind of Postgres specific. It probably applies to MySQL too, which is sometimes it makes sense to store data in a what seems like a less than optimal format, but it's actually more efficient. So the example is we store a lot of time series data, and we don't use a specialized time series database. We use Postgres for storing Postgres time series data, of course, right? And so one of the things we've recently done is we've started using arrays to store some of our data. Right. So imagine you have like a data point, and you have, let's say, there's 5 different values. They're all in the same timestamp. And so the most simplest implementation is you just have, timestamp column, data point 1, data point 2, data point 3, data point 4, all at the same timestamp. And
Mhm.
so what we've done recently, and this has like yielded a tremendous performance, disk space efficiency, but also performance benefits, is we've essentially put more data points for the same customer in one row, right? So the row essentially becomes like a array of timestamps, array of data point one, array of data point two, array of data point three, and such. And what that does is Postgres has various mechanisms how it kind of will reduce overhead in this case. Like it will move some things to secondary storage. In some cases, it will and you avoid the what's called tuple header, which is like each row has like a little header that takes extra space. And so, if for some reason you have a problem that looks like ours, right, then you may want to think about arrays as a way to kind of build a not column storage of sorts, but like it's the kind of thing that the column storage is good at. But if you are in a row-based storage like Postgres, arrays can be an interesting hack there to optimize things.
And then you can just add time series database to the list of things that Postgres can do.
Exactly. Yeah, and I guess I should, in completeness' sake, I should probably say that partitioning is what you should do first. So forget about the array stuff. You should partition your tables if you haven't, right? So like that's the other thing. If you have an append-only workload, which time series data usually is, just make sure you use partitions, because the big anti-pattern in Postgres is if you're doing inserts and you're doing deletes, and so what essentially happens is that you create a lot of these dead rows. Versus if you have partitions, right? Like let's imagine you want to keep 30 days of data, and so you insert each day's data into each partition, and then on the 30th day you drop that partition. And so dropping a partition, like a table partition, is much cheaper than doing a delete statement across millions of records in a table. So.
Gotcha. And then that not only is that more efficient to do, but it also saves you overhead when it comes time to vacuum the database. Is that correct?
That's right. Yeah, exactly. Because the vacuum doesn't have to do the work, right? Because they're not dead rows; they just
they're already gone.
Like you just dropped the table. So
right on. Excellent. Cool. Well, we could continue digging in on this, but I know you've got a meeting coming up here, so it feels like we're at a good stopping point, and then we'll get you off to your next meeting on time. But thanks for coming and talking about this. This has been cool, and it's been insightful. I learned a lot of things about Postgres that I didn't know, despite having used it for a long time.
Perfect. Yeah, and if anybody who's listening is interested to learn even more about Postgres, I host a weekly video series on YouTube called 5 Minutes of Postgres. So if you want to get little like snippet of what's new with Postgres each week, feel free to subscribe to that. And I try to make that as useful as I can to the community. So.
Right on. What's the name of that YouTube channel?
It's just on a Pganalyze channel, but
okay.
The name of the series is 5 Minutes of Postgres.
Awesome. Right on. And then anywhere else that you hang out online that people can interact with you?
Yeah, I mean, I'm on Mastodon. I'm still on Twitter, aka X, and LinkedIn. So feel free to find me online. I'll send you a few links you can include in the show notes.
Perfect.
But generally, if you want to hear more about Pganalyze, just go to our website, pganalyze.com. We host webinars every now and then where we talk about things, how to run your Postgres database, and of course also how Pganalyze can help. But we try to make that generally useful. And then also I'm in a bunch of the Postgres community spaces and Postgres conferences. So if you're at a Postgres conference later this year, maybe I see you there.
Awesome. Right on. Well, thank you so much for joining me on the show.
Perfect. Thank you so much for having me.
All right. See everyone else next week. Bye, everyone.